So dear students, welcome to another lecture of control systems. In this lecture, we will be discussing about the rest of the rules of block diagram reduction technique. So in the previous lecture, we have completed some of the rules. However, in today's lecture, we will be understanding rest of the rules, right? Like when we interchange the takeoff point and summing point, right? What actually we have to do with the original block diagram, right? Then when we interchange two summing points, right? And then if we have to eliminate the summing point, right? How we can eliminate. The first is interchanging of takeoff and summing points, right? So now, for example, if you see in the block diagram representation of an given system, if you notice that there is a takeoff point and there is a summing point falling together, and you notice that if you can shift these or interchange these with one another, it becomes easy for us to simplify the block diagram, right? So in that case, we can shift we can interchange the takeoff point and summing points, right? So what we can say is that if we can shift the takeoff point, let us say, ahead of the summing point. So there may be two cases. One is when you are shifting the takeoff point ahead of the summing point, right? After the summing point, right? And then there is another case wherein you shift the takeoff point, before the summing point, right? So here we are shifting. Okay, so we are shifting the takeoff point from a position before the summing point to the position after the summing point. Okay, so if we have to do so, what we have to make changes in the original block diagram. So this is the original block diagram representation, or this is the original structure wherein we have a takeoff point and summing point falling together with one another, right? So as you can see, this is a summing point and this is a point A. So we are shifting this takeoff point from point A to some point B, right? So RS is coming as an input to the summing point. From here, we have access coming to the summing point as an input. And the output CS is equal to RS plus minus XS. So some of these two signals, right? These two signals. And this is a takeoff point. So we have RS as an output at this end of the branch. Okay. Now, when we have to make change, right? When we have to shift the summing point. Okay, so how will we shift? We simply will, uh, you know, okay, draw or redraw the uh, given representation, right? We'll redraw the given representation. Okay, and this is like, okay, this is RS originally, and this is XS. Okay, so here, if you see, here the output is RS plus minus XS. And here also the output is RS plus minus XS. But this is wrong, right? This is wrong. This should not be there. The output at this point should be RS only. So what will we do to get this output? Okay, so the solution to this is that we need to add a summing point here. We need to add a summing point here, right? And here we have RS plus minus XS. and we need to add a summing point here, xs minus plus, and the output will be rs only, right? So this is what we do. Okay, so this is how we will change the original. So this is original, and this is the what we say as equivalent of the above. Okay, equivalent of the above, right? So now this is the change that we make in the original representation. Okay, we simply have added a summing point here to get the same output rs. So this is how we do, right? Then there is a case when you have to shift the takeoff point. Okay, so from a position after the summing point to a position before the summing point. So this is a position after the summing point, and this is a position before the summing point, right? So now this is the original, right? So if you have to shift this takeoff point in this way, okay, so let us see what original representation has as an output. The output of the original is cs is equal to rs plus minus xs, and this is because a takeoff point. So here also the output is same. So when we shift, we simply what we have actually done is we have shifted this like this. The summing point is here, and this is the output, and this is xs, a signal, plus minus, and this is rs, right? So here we have rs plus minus xs, no doubt this is correct, but here we got rs, which is wrong, right? So what we will do is we need to have xs here, right? So what we have done is we have simply added a summing point in the branch with adding xs in the same summing point, right? So we got this one. So this is the change that we make in the original representation while solving a block diagram using block diagram reduction techniques. Now let us move further. So if we have to interchange the two summing points, okay. So if we see that there are two summing points which are falling in conjunction to one another, or consecutive to one another, right? As you can see here, these two summing points are falling in consecutively to one another, right? In series with one another. So we can interchange these two. Okay, so um, these two can be interchanged by simply placing this in place of this summing point and placing this in place of this summing point. So while interchanging the summing points, or a takeoff point with summing point, or summing point with takeoff point, or moving a summing point ahead of any block, or moving a summing point after a block, okay, and similarly with the takeoff point. So we simply have to remember that the original characteristics of the block diagram should not change, right? So if you have to shift these summing points or interchange these summing points, so you can do so. So let us interchange them. So we have ys here, so we will put ys here, and this is plus, this is rs, and this is minus ys, right? And this we have shifted, okay. So we have xs here, and this is plus, and this is also plus, and we have an output. Right? So here the output at this end is rs minus ys, and when it is added with this one, so we get rs minus ys plus xs, right? So you can see while interchanging, the response remained same. Okay, so this is how it will become. So you have simply changed, you can see. Okay, so the response does not change. Response should not change. Okay, fine. So then we have, if we have to eliminate the summing point, how will we eliminate the summing point? Okay, for example, if you see such kind of representation in the given block diagram, so you can simplify this representation in a single block. Now, if you observe this closely, you will find that this is a closed loop representation. This is a closed loop representation. This is feedback path, and this is forward path. This is a summing point, right? This is reference and all this. So if we have to, eliminate a summing point, or we have to reduce this into a single block, how will we proceed? Okay, it is very simple. So let us start. Okay, let us find out a single block representation of this closed loop representation. So CS. So if you see CS, what is CS? CS is the product of this and this. So CS is GS into ES, right? This is, let us say, equation number 1. And what is ES? ES is equal to, as you can see, ES is RS plus minus BS. So it is RS plus minus BS, where BS is the feedback signal, right? So this is, for example, equation number 2. Now, what is BS? BS is the product of feedback gain and the response, right? Because we have taken response here, and this is the HS is the gain of feedback path. Okay, so BS is HS into CS. So we will substitute this in the error equation. So error equation will be RS plus minus HS CS, right? Now we'll substitute this in CS. So CS is equal to GS. You have RS plus minus, because you know that CS is equal to GS ES, right? So RS plus minus HS and CS, right? So let us simplify this one. CS is equal to GS RS plus minus GS HS CS, right? So you'll take this on this side. Okay, so because it contains CS here and CS here, so we'll take this on this side. So CS mine, now because it is plus minus, so it will change to minus plus now, right? So you have GS, you have HS, you have CS, and here you have GS and RS, right? So you can take CS common. So when you take CS common, so it becomes 1 minus plus GS HS, right? So this is GS RS here, right? So now you can simplify this further. So it becomes GS divided by 1 minus plus GS HS into RS. Now you can take this RS on this side. Okay, so you get CS by RS. So let us move it from this place. Write it here. So CS is equal to, now GS divided by 1 minus plus GS HS into RS. So now CS by RS is GS1 minus plus GS HS, right? So now this is, let us say, equation number 3. Okay. So now this is what you have for this given block diagram. So in this given block diagram, you see you have all these, okay, all these things, all these elements are connected in closed loop. Okay, so you can replace this complete in one go with this transfer function. Okay, and you will get this. So that block diagram has been replaced with a single block. Okay, so whenever you see such kind of representation in the given block diagram, so you can simply simplify that part first of all, right, and replace that with a single block with this formula. So the general formula of this could be, as you can see here, GS is the gain of forward path, HS is the gain of feedback path, and minus plus. So the transfer function, so we can write the overall transfer function of uh, closed loop block diagram is, so it is given by gain of the forward path divided by 1 minus plus gain of forward path into gain of feedback path, right? So this is a general expression of the closed loop representation. So you can simply find out the net gain, or rather we should write net gain, right? Net gain. Okay, so net gain, it should be net gain of this and net gain of feedback path. So you simply have to see that what is the net gain of forward path and what is the net gain of feedback path. Put the values here, right, and you will get the overall transfer function. You don't have to reduce or simplify in this way in that case. Okay, fine. So now in this lecture, we have studied how to interchange a takeoff point and summing point, how to interchange two summing points, and how to eliminate a summing point, right, which with a single block, right? And so this is all about today's class, today's lecture. So now we have covered all the rules related to block diagram reduction. So now in next lecture, we will be doing some numerical on this particular concept. And thank you so much.